go. All right, we got to talk about operations with scientific notation. Scientific notation. SN for short, scientific notation. SN for short. And we've talked about scientific notation already. If you remember, the idea is to be able to write either very large numbers or very, very small numbers. So you want to be able to write either very, very large numbers or very, very small numbers, and that's the idea. One important number that you've got to use for scientific notation, you don't need to write this, I'm just trying to refresh your memory, is 6.023 times 10 to the 23rd. That's a big number. It's the 6 and then 23 places after the 6. It's gigantic. It's a very, very big number. It's also an important number. It's called Avogadro's number. And it's actually an amount. Like if I said a dozen, you would all say, if I said a gross, you would all say 144 is a gross. I have no idea how much is in a peck, but that's a farmer's measurement. If I said, what else could I say?
Half a dozen.
Yeah, that's kind of obvious. Baker's dozen? 13. All right. Well, 6.023 times 10 to the 23rd is a mole. All right, not the mole in the ground. Any of you guys have moles at your house? We have moles all over the place. Moles at your house? Luke, don't you have moles? You guys don't have moles? I thought they're like in our whole neighborhood. I'll have to try to shoo them away from my house down to yours. But no, I wouldn't wish moles on anybody. But 6.023 times 10 to the 23rd is it's called a mole. Just like a dozen is 12, a mole amount of something is 6.023 times 10 to the 23rd. Big number. All right, so again, scientific notation, what's it for? Writing very, very large numbers or very, very small. Well, what we need to concentrate on this lesson is not simply writing a number in scientific notation, but being able to add or subtract numbers written in scientific notation or to multiply or divide numbers written in scientific notation. So that's the idea, and that's what we're doing. All right, so how do you add or subtract them? All you got to do is follow everything in this box, and you're good to go. All right, hopefully you can do that. So I'm going to grab my green here, and the first thing is add the coefficients. COE, FF, IC, IENTS. COE, FF, IC, IENTS. So the first thing is add the coefficients. So remember what a coefficient is. It's a multiplier of a number. Well, with scientific notation, that's a little bit different. So off to the side here, let's write a number in scientific notation. Let's do 7.5. I'm doing that part in green. Then take your blue. I'm going to use a blue X, remember, and it's times 10 if you remember that. And then if you remember, there's some exponent. And I'm going to put a 7 there. So if our number were 7.5 times 10 to the 7th, the coefficient, the multiplier of the power of 10 is 7.5. Okay? So when you're adding or subtracting numbers in scientific notation, you have to add the coefficients. Write the solution in proper scientific notation, and remember in doing that, the first digit has to be between 1 through 9. First digit has to be a 1 through 9. Has to be. Has to be. All right, 3 is an if-needed situation. Here's the reality. You need to pay attention to this statement. Don't let it go over your head. In order to add or subtract numbers in scientific notation, and I'm going to take my red, I'm just going to go up here and put an asterisk. In order to add them, they must have the same power of 10. So, they must have the same power of 10. In other words, the exponent has to be the same on the 10th of that exponent. So if we want to add or subtract this 7.5 times 10 to the 7th, we want another scientific notation number with whatever times 10 to the 7th. The powers need to match to be able to add them. You simply add or subtract the coefficients. What if they don't match? You have to make them match. That's the tricky part. So if needed, put them in the form where the powers of 10 are equal. If needed, put them in the form where the powers of 10 are equal. So really what we're really doing is we're taking a number that is in correct or proper scientific notation and we're putting it in improper scientific notation. I'm going to say, Mr. Scarfi, why would we do something like that? Okay, let me try to make an analogy. When we were adding fractions, if you had 1/6 plus 1/2, are we ready to add those fractions? The answer is we're not. And aren't we going to change the 1/2 to a 3/6 so that we can then add them? So didn't we change the form of that 1/2 so they'll add? It's the exact same thing we have to do with scientific notation. In order for us to add them or subtract them, the powers of 10 have to match. And if not, we'll have to modify one of them to get the power of 10 to match. Now, is 3/6 the same thing as 1/2? Yes. Obviously, we can't change the value. So we have to learn how to change the form of a scientific notation to get the powers to match and still be equal. And that's what we'll learn to do. But that's the idea. You got to change it. Do this by changing the one with the smallest power of 10. That's a big clue and an important thing. If you try to do the largest, it's harder. I'll show you what I mean in a minute. I'll give you some examples. Again, I know this is just words, doesn't mean as much right now, but we'll get there. And then second, with the 2 asterisks, for every place you move the decimal point to the left, you increase the power of 10 by the same amount. And I'll give you a little bit easier way to understand that in just a moment, all right? Basically, here's the bottom line. If you're going to add or subtract scientific notation, you got to get the powers of 10 to match the exponents. If they already match, great. Just add up the numbered parts and give it that power of 10. If they don't match, you're going to have to change one of them. Change the one with the smallest power of 10, and then you'll be able to add them. And I'll show you what that means in a minute. Again, that may not mean a lot to you right now. Let's do some examples, and I think it'll begin to make sense to you. Now, the first example is pretty easy. The powers of 10 match. Now, before we write this, let me again make an analogy. Don't write this next thing. I'm going to go all the way. I'm going to go higher so you guys can see it. Okay, so let's suppose we've got this first situation. When we were doing like terms, and we did this earlier in the chapter, don't write this. If I had 7x plus 2x. 7x class plus 2x equals 9x. So you said 7 of them and 2 more of them is 9 of them, correct? We could have also written it like this. 7 plus 2 of the x's, yes? What did we just do? We just added the coefficients. A scientific notation is the exact same concept. We use that x there, but we could use a raised dot just as well. And I could use a raised dot here. 7 times x plus 2 times x equals 7 plus 2 times x. So with that in mind, that's kind of what we do here with our scientific notation. So just for clarity's sake, I'm going to take my green and I'm going to do the coefficient part. 7.1 plus 2.5. Those were the fronts. Do you agree? Now, whatever that adds up to, it's still, I'm going to take my blue now, times 10 to the third. 7.1 of the times 10 to the thirds plus 2.5 of the times 10 to the thirds equals, what is that, 9.6 times 10 to the third. Final answer. That wasn't too hard. Christina.
Solving anything.
We are simplifying. We're adding up the numbers. We added a 7.1 times 10 to the third, and we added it to a 2.5 times 10 to the third. And when you add them up, you get 9.6 times 10 to the third. Just like if you were to add 3 plus 4, your final answer would be 7. When you add up two numbers in scientific notation, your answer will be in scientific notation 99% of the time. So again, the second one, right, we're going to do the green part first. Only this time, would you agree, I'm going to do 8.31 minus 5.2? Now again, we can do this because the powers of 10 match. And it's times 10 to the negative fourth. And it doesn't matter if the power is negative, positive, or whatever. As long as they match, that's going to be the power of 10 part. Now, after Thursday, when you get your calculator, you would just punch in your calculator 8.31 minus 5.2. You don't have your calculator yet, but if you were to do that, can anybody do that in their head? 8.31 minus 5.2. Colby? It is 3.1 and not 3.11. I agree. I'm like, no, yes. All right. And again, if you can't do that in your head, do it on the side until you get your calculator. Just do a little subtraction problem on the side. But don't forget the power part times 10 to the negative fourth, and that's our final answer. That's what happens when you do those two. All right, D is unique. Our powers still match, so that's good. But look what happens when we add the green parts. So in this case, we're going to do a 5.8 plus a 7.02. And again, of the times 10 to the fifths. 5.8 plus 7.02 of the times 10 to the fifths. All right, so if you added that up, you would get 12.82 times 10 to the fifth. How come we're not done on this one? How come we're not done on this one? Juliana? Yeah, your front number has to be a 1 through 9. In other words, it has to be a number and then the decimal point. And we don't have that. We have 12.82. Now, by the way, this is true. The number's correct. It's just not in the correct form. You just don't leave it in that form. 12.82 times 10 to the fifth is the correct adding of those two numbers. It's just not in the proper form. The proper form is to have the front number to be between 1 and 9. So what we have to do is we've got to move this decimal point one place to the left. Our new number in the front is going to be 1.282. Do you agree? Okay. Now here's what I'm going to teach you in how to get the power correct. Is 12.82 bigger or smaller than 1.282? Bigger. So did we make the number bigger or did we make the number smaller? We made it smaller. So going this way makes it smaller. Therefore, I have to make the power of 10 bigger to counteract it. If I make the front number smaller, the power of 10 has to become bigger. By the way, if I make the front number bigger, I have to make the power of 10 smaller. How many places did I move the decimal point? So how many places do I make it bigger? One, right? Math makes sense. So it's going to be times 10 to the 6th. Because I had to move the decimal point one place, and I made my front number smaller, I will make my back number larger. Okay? And those are equal. They're exactly the same. 12.82 times 10 to the 5th is exactly the same as 1.282 times 10 to the 6th. Exactly the same. So sometimes that'll happen to you when you're adding or subtracting, multiplying, dividing scientific notation. Just be ready for it and finish it off the correct way. Always finish it off correctly. You can see E's a little bit different yet. With E, what we've got here is we don't have the same power of 10. The front number is to the 5th and the back number is to the 4th. So way back up here I said to change the 1 with the smallest power of 10, right? Now, what do I need the power of 10 to be? It's currently a 4. I need it to be a 5. So did the 4 get bigger or smaller? Bigger. This Windows 10 is doing strange things, so this thing keeps flipping on me. So I want this to be times 10 to the 5th. So smaller number, but this got bigger. So what do I want to do to the 7.3?
Make it bigger. Smaller.
It's always opposite. Therefore, this must go smaller. So I went from a 4 to a 5. I increased by how many?
1.
So I got to move the decimal point 1 either left or right to make the number smaller. Which way makes the number smaller? Moving left or moving right?
Left.
Moving left. So our number is going to be 0.73 times 10 to the 5th. Do you agree? That's a little tricky, I know. Let me clean this up a little. But where we ended up was 0.73 times 10 to the 5th. Now we are ready, and there's still a plus sign in front, right? Now we're ready to add those two up. Okay, so let's use our color. Let's grab our green. The front, do you agree, is a negative 3.4? And the back is a positive 0.73. And our power is going to be times 10 to the 5th. All right, now you got to be careful. You got to add a negative 3.4 and a positive 0.73. Some of you are going to have a hard time doing this. Again, once you get a calculator Friday, you'll just punch in your calculator negative 3.4 and positive 0.73. But remember, 0.73 of these will wipe out 0.73 of these, won't they? All right, it's a little tricky. If I did 0.4 of these, right, it would wipe out this 0.4, and now I'm down to negative 3, yes? How much more do I have still to go? 0.33. If I'm already at negative 3, 0.33 wipes out 0.33 more of these. Where do I end up? Can you do that one in your head? It's tricky. Where am I at now? Anybody? Colby?
2.27.
So it is negative 2 points and not 2.7. I got 0.33, wiped out 0.33, out 33 out of 100. How many's left? 67. Again, it's tricky. That's tricky. I'll try to avoid some tricky ones for you that way until you get your calculator, so you don't have to worry about doing the addition. All right, let's look at one more of this kind. So notice again, now we have negative powers of 10. Do they match? Yes or no? No. So our powers of 10 don't match. So remember, we have to change the smaller number. Which one is, don't say this one out loud, I want you to think. Which one is smaller? A 10 to the negative 7 or a 10 to the negative 5? Which one is the smaller? All right, on 3, you're either going to say negative 7 or negative 5. Which one is smaller? 10 to the negative 7 or 10 to the negative 5? Here we go, 1, 2, 3. Okay, I heard a lot of 10 to the negative 7, and it is correct, right? Remember, the higher the negative exponent, the actually smaller the number. So 10 to the negative 7 is the smallest. Now, what do we want the exponent to be? We want to go from a negative 7 to a, so we want 10 to the negative 5th. Did the exponent just get bigger or smaller? Bigger. From negative 7 to negative 5 is bigger. By how many places?
2.
So if we made the power bigger, we have to make the front
Smaller.
by how many places?
2.
2. Can you make the front smaller by 2 places?
Yeah,
Just move the decimal point 2 places to the left. So there would be 1. You got to use a 0 placeholder and move it 2. So 0.56. Remember, to make a number in the front smaller, move the decimal point to the left. We all know that 0.056 is smaller than 5.6, right? You all know that. And again, you don't worry about the positives or negatives, just go that direction. And the back is good. Now we're ready to add them. So again, if we were going to be technical, and I do want to see this step in your homework, because again, it's just reinforcing what you're doing. So now you have 0.056 plus 3.8, and remember it's times 10 to the negative 5th. This one's not as hard to add up. Again, if you need to, until you get a calculator end of the week, do it off to the side. If you were to do this off to the side, you would go 3.8 plus 0.056. And can you clearly see that you end up at 3.856? Okay. But again, if you can't do that, do it off to the side. And this is times 10 to the negative 5th. Now, what if we got to this point and this front number wasn't a 1 through 9? Then we'd have to change it one more time, right? Sometimes that'll happen. What if this would have ended up 0.3? Is that good? No, can't have a 0 in the front. We would have moved it one place to the right. We would have made the number bigger. Therefore, we'd make the power of 10 smaller. If this would have ended up 38.5, we'd move it to the left and make this smaller. Therefore, we make the power bigger. They always go opposite. If you just remember that, you can be okay. They go opposite. All right, that's that one. That's adding and subtracting. Guess what we get to do next? Multiply and divide. Ooh. Yeah. Okay, let me do an analogy for you first. Don't write this. If I had 2x times 3x, now don't I get 2 times 3 is, but x times x is x times x is x squared. Multiplying is different than addition. We multiply the 3 times the 2 and the x times the x. We're going to have to do that here. Oh, this thing is driving me crazy. I'll get used to it, I guess. Right now, I'm not used to it. Okay, so how do you do it? Take your green. In this case, now you're going to multiply or divide the coefficients. I-C-I-E-N-T-S. C-O-E-F-F-I-C-I-E-N-T-S. Multiply or divide the coefficients. Depends on what you're doing, right? And then, I'm going to do this part in red, apply the proper exponent rule. Hey, remember we learned exponent rules? You know how I put them on every test in that little rules section? All right, well now we got to apply that. If you were doing, look at this first, don't box it, I'm just doing it to focus your attention. 10 to the A times 10 to the B. Somebody raise your hand and tell me to finish the rule. Edward.
10A plus B.
Correct. The exponent is A plus B. We add the exponents. If you had 10 squared times 10 cubed, you would end up to 10 to the 2 plus 3 or 10 to the 5th. You add the exponents. Hey, before I go any farther, to multiply or divide, scientific notation, do the powers of 10 have to match? No. Multiplying and dividing are different than adding and subtracting. Adding and subtracting, powers of 10 have to match. Multiplying and dividing, they don't have to match. All right, let's look at the division rule. Again, I'm just boxing to focus your attention. 10 to the A divided by 10 to the B equals 10 to the Allison, A minus B. That's how you do the powers of 10. So look, if you're multiplying, you multiply coefficient times coefficient, power of 10 times power of 10. If you're dividing, divide coefficient by coefficient, power of 10 by power of 10. Voila. And of course, always make sure your final answer is in proper form. So write the answer in proper scientific form. Again, the first digit must be 1 through 9, right? All right, let's see how this shakes out. Example 1. So example 1 is a multiplication problem. So to help out, I'm going to do it with parentheses. And the first thing here, I'm going to start off underneath. The first thing I want is the 2 times the 3.4. Do you agree? And then it's going to be, I'm going to do this part in blue, times 10 to the 2, I'm going to take my red, plus 5. Now I'm doing the power of 10 part, right? 10 squared times 10 to the 5th is 10 to the 2 plus 5, right? And I'm showing that rule step right there, which is great. Okay, some of you, again, until Friday when you get a calculator, you may have to do this on the side. Most of you can do in your head, what's 2 times 3.4? 6.8. And hopefully we can all do 2 plus 5 in our head. All right. Are we in proper scientific notation? 6.8 times 10 to the 7th? Yeah. Yes. And so that's our final answer. The front number is between 1 and 9. All right. We multiplied the coefficients, the 2 times 3.4, and we multiplied the powers of 10. 10 squared times 10 to the 5th. Multiply, multiply, it's a multiplication problem. Let's try the next one. Second one, similar. Uh-oh, we got a positive number and a negative number. Is that an issue? What's a negative times a positive? So we're expecting this number to end up negative, right? A negative 5.1 times a 3.7. Now, quite honestly, I'm not even doing that one in my head. So off to the side, I'm going to do the 3.7 on top and the negative 5.1 on the bottom, just because I like having that 1. Could do it either way, right? Commutative property, right? Either negative 5.1 times 3.7 or 3.7 times negative 5.1. So again, I'm going to stick my negative right in the beginning so I don't forget it. 1 times 7 is 7. 1 times 3 is 3. 5 times 7 is 35. Carry the 3. 3 times 5 is 15. And 3 more is 18. Add it all up. I got the negative. I got 7, I got 8, I got 8, I got 1. Where does the decimal point go? Do you guys remember? How many places? 2, right? Because 1 place for that one place for that one, so 2 places in. So I have a negative 18.87. That's my front. Powers of 10. There's my times. There's my 10. I have a 3 plus a negative 8. Does that make sense to you? Remember, we're multiplying the powers of 10, aren't we?
It's negative 3.
Is that? It's not an 8.
Ours says negative 3. Yours says negative
Did I change it? Are you serious? All right, make it a negative 8. Yours really says negative 3? I must have forgotten to change it on your notes. Just make the 3 look like an 8. That's pretty easy. Mine's definitely an 8, right? I know my eyes aren't the greatest anymore, but that's definitely an 8. Okay, so our power of 10 ends up being times 10 to the negative fifth. Are we in proper psi notation? The answer is no. Okay. Just be careful here. Don't worry about the positive or negative. Don't worry about that in the front. I went from an 18 to a 1.8. Did I get bigger or smaller? Smaller. I have to make this, therefore, bigger. It was smaller by 1, so hopefully you all agree the front is now negative 1.887, and the back must be times 10 to the, you got to be careful, it's tricky, right? It is a negative 4, right, is bigger. The less negative, the bigger the number, right? I know that's tricky, but that's the way that works, okay? Made the front smaller, got to make the power of 10 bigger. If we would have made the front bigger, we'll make the power of 10 smaller. All right, one division example. On this one, I don't think anybody's doing this division in their head, right? So again, I'm just going to go off to the side. Remember, the 3.5 gets divided into the top, the 1.47. Now, do you guys remember you got to move the front decimal point to the right one? Right? Therefore, what do you do to the decimal point in the 1.47? You got to move it to the right one, okay, to make this work. Does 35 go into 14? No. 35 into 147. How many times? 35 times 2 is what? 70. 2 70s is how much? 140. So that would be a total of 4 of them. Again, if you can't do that in your head, you're going to have to try 3, and then you'll see you have too many left, and then you'll try 4. All right, 4 times 5 is 20. 3 times 4 is 12, and 2 more, again, as we just said, is 40. That's 140, right? Subtract. We get 7 left. We got to take a 0 down, bring that 0 down. Oh, good. 35 goes into 70 2 times, right? No remainder, thankfully. Hey, if we got a remainder, we may have to actually end up doing a ... get to the repeat part. We're going to try not to give you ones like that right now because we really want to focus on how to do the scientific notation. So hopefully you agree the front part is 0.42, right? So Raph, what do I do with the power of 10 part? It's a division problem. How do I do my powers of 10? 10 to the what? Correct, great. And he said it exactly the way I was hoping. He did 12 or 10 to the 12 minus 7, right? Take the top exponent and subtract from it the bottom exponent. So here's where we're at right now, 0.42 times 10 to the 5th. Are we done? No. We're not in proper scientific notation. Why don't you finish this one off? And we'll see in a minute if you did it correctly. Hopefully everybody knows the front's got to be 4.2, right? And therefore it's times 10 to the 4th. Your front number got bigger, therefore your exponent had to get smaller. How many got that right? Oh, you guys are brainiacs, I'll tell you. You're awesome. Right. Scientific notation, look. Question and then hang on. I need to do one thing before we finish. Yes.
Does that say 4.2 times 10 to the 4th?
Okay, so this had to go this way to get the front number to be 1 through 9, correct? And I just made this number bigger. So this got bigger. Therefore, this must get smaller. Okay? To make it in proper form. The other one was true, just wasn't the correct final form. All right, so class, look. Let me just refresh your memory. Don't get confused between adding, subtracting, multiplying, dividing. They're different. How do you add scientific notation? You got to have the same power of 10. If the power of 10 is same, add the coefficients and give it that power of 10. If the powers of 10 aren't the same, you're going to have to change one of them. Change the smallest number. That's the easiest way. And then you're ready to add or subtract the coefficients with that power of 10. However, to multiply or divide, you don't have to worry about the power of 10. You can multiply any scientific notation numbers regardless of the power of 10. Okay, without changing anything. And it's multiplying front times front, power of 10 times power of 10. Remember the exponent rule. Dividing, right? Top one divided by bottom coefficient, power of 10. Again, the proper way to divide powers of 10. That's scientific notation. Always at the end, make sure you're in proper notation. All right, that's it for today.